Hello, everybody. Thank you. And let's hear it again for Tanya and Maud. Thank you so much. All right. Well, I am very glad to be here today. And I wanted to open up the conference a bit by bringing our attention to the way we conduct ourselves as engineers. And here, where I'm talking about engineers, by the way, I don't just mean people who are writing code. I'm talking about everyone who works on the discipline of building systems to solve problems. So if you're a software developer, a product manager, a QA engineer, a UX developer, any of the other members of our shared profession, this is for you. Oh. Thank you. Can you hear me now? Awesome. All right. I will also say that Tanya asked me not to bother with subtlety for this talk. So, you asked for it, you got it. Content note, just being serious. We are about to talk about some pretty serious issues. There's going to be injuries, death, stalking, domestic violence, various other things. I'm not going to be getting into graphic details, but we're going to talk about some pretty serious stuff. And hopefully by the end of this talk, you'll understand why we need to talk about some very serious stuff. So, since its inception, the focus of our field has been rapid innovation. Right? Now, we've invented new technologies for everything from computing to communications, personal computing, gaming, industrial control, office automation. And we tried these ideas out on one another. We developed tools for ourselves. We built a thriving open source community. And as the saying goes, we would move fast and break things. Because ultimately, the consequence of doing something wrong was usually pretty limited. Except when it wasn't. Turns out it matters which office you're automating. And if you don't recognize this, by the way, this is from the Racial Purity Office of the SS, a nice little punch card manufactured by one of our major companies still today. So what did we do? We tried to split up our profession. We had the serious bits, right? Medicine, rocketry, places where you have to do serious testing and people are writing in Ada and paying attention to detail and wearing ties and having Gantt charts and things like that. And then we had the fun stuff. The things that happened in Silicon Valley, the places where everyone would just innovate as quickly as they could, crank out the best ideas they had, iterate until they worked, see if you can get that product market fit, create the magic. And it worked. What we did actually succeeded. The technologies we build today are fundamental to nearly every aspect of human life. These are where people make friends, where they find jobs, where they build communities. And they're also where people build other kinds of communities. They're where people lose jobs to automation, where they get bullied, harassed, stalked, live or die by the systems that we build. What we do matters. Today, if the software you're building matters at all, it matters a lot to real people. When we build systems right, people thrive, and when we build them wrong, people suffer. The consequences of our mistakes, they're measured in millions of dollars if we're lucky, in lives ruined, in lives lost, in democracies overthrown if we aren't. We have succeeded as a profession, and that means that what we do as a profession matters. And with great power comes great responsibility. So what do we do about it? You can split all of engineering into two basic categories. Product engineering is about how systems should work, and safety engineering is about how systems should fail. We are kind of unusual in treating these as distinct. Most engineering disciplines don't do this. If you hang out with civil engineers, they're basically safety engineers who will occasionally build bridges. We separate them, and we train our young engineers almost exclusively on product engineering and all of safety. And by safety here, I mean security, privacy, reliability, abuse, all these things. These are things that we think about afterwards, or that your specialists deal with. And if you've ever tried to retrofit security or reliability into a system, you know why that doesn't work. We can't do that anymore. This is not working. Safety needs to be as fundamental to our work as breathing. So, okay, why am I telling you this? Why am I haranguing this particular audience about this? Because as StaffPlus engineering leaders, you are the key to this happening. You are the leaders on the ground. You are the ones with your hands in the code and on the system. You are also the people that your teams and colleagues look up to. You are the ones that young engineers are going to be looking to model the highest standards of our profession. What you do, they will learn. So, okay, I'm not going to try to cram an entire course on safety engineering into a couple more minutes here. What I am going to do is I'm going to talk about some basic principles. I'm going to walk you through a couple of specific cases to show you what went wrong, how things do and don't work. And finally, we're going to talk about how, as a practical matter, you can actually build a safety culture. So, all right, let's start with the basic principle. Every safety framework you ever encounter, if it's like a NIST framework or ISO or something like that, or whatever, everything ultimately boils down to 2 points. First one is, you need to know the ways your system might fail as intimately as you know the ways your system should work. So what that means is that from the very first moment that you get an idea for a system, when you're just even first having those vague ideations and you're imagining features, at the same time you're imagining failures. You're imagining misuses, things that can go wrong, and you're not doing this one-off. It's not just a one-time thing. You're doing this continuously, just in the same way that you keep thinking about the ways your system can be used and how that changes. And I should say, this part is not easy, because unlike thinking about the ways your system might work, where if you miss a use case and that turns out to be a happy surprise, when you miss a failure case, that's the opposite of a happy surprise. What you don't know can very much hurt you. And what you need to do for that is you need to have many eyes on the problem, and you need to plan for surprises. Unknown unknowns. Oh, good idea. Yeah. Unknown unknowns are probably a better way to do it, are something you need to be paying attention to. And second, for each of these scenarios, you need to have a plan. In the best case, you can completely eliminate the risk. Sometimes you can reduce its severity or its frequency, or you can give users a way to resolve it themselves, which makes it less serious when it happens. In pretty much every case, you need to have a response plan ready for when things go wrong. Be able to detect, know what you're going to do. And I'm saying when, not if, by the way. To quote something one of my friends and colleagues said, if something happens to 1 in a million people once a year, here at Google, we call that 6 times a day. That is, unfortunately, very accurate. Excuse me, I just absolutely needed some water. So, that brainstorming, that's actually a pretty hard step. I'm actually right now working with my team on developing training materials to help people do it. But to give you sort of an overview, how do you do this brainstorming? I tend to recommend a 3-pronged approach. You do one pass that's system first. Right? You think about the components of your system. What happens if each one fails? What happens if it gets bad inputs? Things like this. You're probably used to this from just ordinary system architecture. Remember here, though, your components include the users. Don't draw an artificial boundary around your system saying, oh, this part is my responsibility, this part is someone else's. Think about what happens if the user doesn't understand the system, or if they're trying to do something different from what you intended, or if they don't phrase their request exactly the way you thought they might. Then you can go over your system actor first. What might someone want to achieve using this software? How might they do it? Under what circumstances are they using it? Think about adversarial actors. Think about people whose interests aren't necessarily aligned with yours. What might a bad actor be trying to accomplish using your system? This is actually a really important one because sometimes people will try to really protect the secrets that they care about, not realizing that the secrets that adversaries care about are actually totally different. Think about those circumstances. Is someone going to be rushed? Are they going to be under pressure? Will they be facing social pressure to use the system in a certain way? Think about things that can go wrong from there. And finally, think target first. There's a lot of people who can be affected by your system, right? Not just the people who are directly using it. If you're making a system that shares photos, what about the people who are in the photos that are being shared, even if they're not directly party to it? If it's a system for, loan applications, the person who's applying for a loan might not be directly using your software. It might be used by people at a bank, but they're certainly affected by it. What are things that might make a person more or less vulnerable to the consequences of the software? How might people like this be able to respond? This is also the moment where diversity really, really, really matters. We talk all the time about DEI and things like that. This is where the rubber meets the road. You cannot do this step if you don't understand the lived experience of all of the different people who might be affected by your system. And the one thing I can promise you is that you personally don't. because there are 8 billion people in this world, and I can tell you that this room is really not a uniform random sample of them. You need to have a very diverse team, and you need to empower people to be speaking in that team and bringing things up. And I'm actually going to have some concrete examples of that one in a moment, because otherwise you're going to miss things and that results will be bad. All right, example time. Let's start with a little device called Therac 25. Did I hear some giggles in the audience? Okay, good, you know where this is going. This was a computer-controlled radiation therapy system. It was launched back in 1982. And just to give you some context, this thing has 3 modes. There's a setup mode where it projects a sort of pattern on a patient's body in order so you can position them well. It's got an electron beam therapy mode where you fire a low current electron beam into their body. And it's got an X-ray therapy mode where you're firing a photon beam into the body. And the way you create that photon beam is you take that same electron beam, but you fire a high current beam into a tungsten target. And when electrons strike tungsten, you get X-rays like that. Now in the previous models, Therac 6 and 20, those modes were selected with an electromechanical interlock. Therac 25 used software. And as we all know, software never fails. This is totally safe. Nothing could possibly go wrong. Yeah, so there was a race condition that if you selected X-ray mode and within 8 seconds you switch it to electron mode, it left the beam in high current mode, but without a tungsten target in the way. By the way, high current was like 100 to 1,000 times the power of low current. So this is what's known as a death ray. There's also this miscellaneous bug where sometimes the electron beam would just fire while it was in setup mode. Surprise. 3 dead, 3 severely injured. One of those severely injured probably would have died from this, but they were actually killed by their cancer even faster than they were killed by their injuries. Consequences. Okay, what went wrong here? There was a pretty detailed investigation, and what we found was that it wasn't that there was a single particular flaw that drove this, but there was actually a pattern of poor design across the whole system. There was no safety check for never happens configurations, like we are in high power mode and there is no tungsten target in the way. In the old systems, there was a physical interlock. Now there was just no check to make sure that the configurations made sense. There was very little feedback in the system that let you compare the actual state of the system to the state the user had requested. This is actually a pretty common sort of UX design mistake that can happen. You have like a switch to move it into a particular position, and I hope that it actually did move into that position because you don't have a way to check the real one. The errors, literally, like if it had an error, it would say something like malfunction 54, and good luck finding out what that means. It wasn't even in the manual. It didn't distinguish safety critical issues from ordinary issues, and so operators got used to just hitting proceed because 99% of the time that was the right thing to do. So what are some key lessons we take from this example? First of all, in a complex system, define your safety invariants and check for them. It shouldn't be possible for the system to run in a bad state. Second, safety needs to include the operator flow. Operator error is a euphemism for UX failure. Real people are going to be using the system in real situations. If it's easy to make a dangerous mistake, you have built your UX wrong. It needs to be easy to do the right thing, possible sometimes to do the complex thing, but you should never be able to do the dangerous thing by accident. And remember, when you're doing this, UX is not just software. It includes process. It includes the ways in which humans are going to actually use this in their day-to-day lives. Think of every system you build as a socio-technical system, where the users and the humans involved in it are components, and they need to be thought about and evaluated and examined just the same way that all of the hardware and the software does. All right, example number 2. Google Plus. Does anyone here remember Google Plus? Awesome, okay. So, Social Network launched in 2011. I was Google's CTO of social at the time, and so I am one of the people who is personally responsible for this particular fuck-up. This network we sort of built it with a privacy focus, right? We introduced this concept of circles of friends. There was a lot of access control going on. But at launch, in fact, only 3 fields in your profile had to be public rather than ACLed. Your name, your profile picture, and your gender. Now, why these 3 fields? It was UX reasons, right? If you're showing a comment or something, you want to show the name of the person who did it and a picture of who they are. And why do you need the gender? You need that to form sentences in the UX. right? In most languages, the sentence X shared a picture with you, you need to know the gender of you, of X, or both. Really simple, really straightforward reason. Okay, cool, make all three of these fields public. Couldn't be a problem, right? Nothing could go wrong here. Yeah, so starting more or less instantly, people were scraping the service to find women and share links to their pictures. And we got all sorts of wonderful categories of users. NBUMMs was one of our standard names for these groups. They would show up and say, nice boobs, you marry me? We had many more, many of them less savory than this as well. This did not create an environment that really encouraged women to stay on the site. And that's a problem. Right? In social networks, your initial population sets the culture shapes the future population. We had just invested a ridiculous amount of money in building this thing and built a culture that drove women away. And by the way, if you know anything about social networks, women are what make or break the success of a social network, right? Because the rule is women want to be where other women are and men want to be where women are. And if you drive women away, you do not have a good thing. We managed to materially and negatively affect the success of our product during the critical early months when public opinion was forming. What are some big lessons here? Obvious ones: without diverse opinions in the room and being listened to, you are going to miss threat scenarios. I was in the room when we made this decision, and in retrospect, looking back, it's like, oh yeah, everyone in that room was a guy. There was no one who had the experience of, oh wait, women have a slightly different experience on the internet than men do. And when one of our PMs, Frances Haugen, you might have heard of her, she raised a red flag a couple of weeks before launch, and we didn't prioritize fixing it. We were idiots. This was a mistake. All right, example number 3. You might have read about this one in the paper recently. Basic problem: domestic violence kills thousands of people every year, and police resources are very limited. So why don't we use data to optimize the use of scarce resources? Good CS sort of approach, right? The implementation turned out to be a 35-question yes or no survey, which was meant to be administered by police when responding to a domestic violence incident. The outputs of that feed into an ML model that gives a 5-level risk classification, which in turn shapes police response. This was deployed across Spain. As a safety mechanism, police and judges and so on were being very encouraged to use their better judgment and override it when needed. So, if you are saying, oh shit, right now, then congratulations, you've been paying attention. You can probably guess that this is about to go very badly. What actually happened? First of all, this override was a joke, 95+% acceptance rate of system predictions. Of the 247 dead so far, they did a deep dive into 98 of them. More than half of the people killed had been classified as negligible or low risk by the system. And if the system classified you that way, if it said you were negligible or low risk, not only was police assistance basically no longer available, but this is now actually evidence in court against you getting a restraining order and things like that. And what's interesting is, by the way, this product might actually be working overall at reducing deaths. It's a bit too early to really have reliable statistical information. So this might be net successful, but if it rates you at the low end of the threat scale, you are suddenly in a lot of trouble. So what did they miss? Biggest problem: garbage in, garbage out. The world's best model will not help you if you get bad inputs. People being abused usually depend on or fear their abuser. And now you're suddenly asking them to give honest answers to intimate questions to a usually male stranger who was selected in part for their machismo. They might well have ties to your abuser, especially if you live in a small town. Did they think they were going to get good data here? The people most in danger are the people most likely to lie. On top of this, the incentives don't align. Remember, this was being sold to police as a way to reduce load. But now, if you want to override this thing and actually pay attention to a case that it says to ignore, not only do you have to do that work, but you also have to justify the fact that you're overriding it. You've actually made it harder to do the right thing. There was no attempt to make this resilient to things like bias on the part of the officers, insider threat, things like that. Also, a lot of assumptions got made. The whole thing assumed that it was a male abuser of a female victim, that the cop is a disinterested but trusted neutral helper, all sorts of things like that. And of course, the really fundamental assumption, is routing police more effectively even the thing we want to do? I can tell you that if you talk to most domestic violence support advocates, they're not going to say, oh boy, what we really need is a more efficient use of police. A lot of things went wrong here. So what are some key lessons? A lot of good researchers worked on this, and really obviously not enough of them were operational. There's a big difference between professors and operators. This whole what could go wrong modeling should have been the very first thing they did, and if they had done so, this system would have been designed differently. A lot of effort went into testing and validating that core component, the ML model. And the problem is, most failures in real systems don't happen in components, they happen at the system integration level. They happen when something falls between the cracks of two different parts. Ultimately, also, you can make a system that works great in the common case, but the failures, rather literally in this case, are a killer. You've got to watch out for those edge case failure modes because those can have a cost that completely swamps the value of the entire rest of the system. Okay, given you a couple of examples. Now let's talk a bit about the practicality of how we actually do this ourselves. Staff engineers usually aren't the final decision makers in companies, so how do you actually make this work in your real environment? And there's two basic ways you're going to do this. There's bottom up and there's top down, and you need to do both. So let's start bottom up. People mirror the attitude and behavior of people they respect. And you, people in this room, you are the leaders your teams interact with the most. If you create a culture of safety, your team will follow. So how do you do that? You need to understand and master safety. And then you need to be the one raising safety questions. Every time, if you're doing a design review, a code review, a launch review, just in ordinary conversation, raise these questions. Get people used to the fact that these are questions that are going to be raised. Get people to expect to be asked about safety so that they're preparing that answer in their head because they know you're going to ask about it at the next meeting. The way you know that this is working is when people start asking those questions themselves. Right? You set that culture, suddenly you see other people setting the culture themselves. You've now built a stable working culture. You also need the top down. You need senior allies, and you need to be ready to escalate. And that's because tensions between safety and other business needs happen all the time. Right? It's like, do we spend more time tuning the system or do we launch now and tune it later? And those decisions are never simple. Right? It's not a simple always do safety, always do business. The right answer is complex. You need senior allies who understand this that you can escalate with. And you get them involved by showing what the stakes involved and showing them the method, showing them how to do safety, while simultaneously being really responsible about the larger context of the business. Now you might be thinking, well, that's great, but what if they don't care? And the answer is people don't care for different reasons, and what you need to do about it depends on the reasons. Right? So sometimes they just aren't used to thinking about it. Remember, we train engineers and PMs and so on to be product engineers, and they got that same thing. Sometimes you just need to educate them, you just need to show them these things and get them into that headspace. Sometimes there's a particular issue that hits home with them. There was a senior exec I used to work with, and we'd always go back and forth over all sorts of things, and one day we had an issue, and I told him about an issue that could lead to stalking, and his eyes went as wide as dinner plates. What I found out later is that his best friend had had a stalker, and so he knew exactly what this was like, and the moment I said that, just everything clicked for him. Never had to have a discussion like this again. He was on board 100% from that day on. Sometimes you need to tie it to product success or the metrics that people are already being evaluated on. Remember, an unsafe system is one people don't want to use. It's one that gets bad press. Part of the point of that Google Plus example is you can destroy your own product by getting these things wrong. Sometimes people just need to know that their personal asses are on the line. This is the point where regulation can be your friend. Regulation also helps this problem of the "but our competitors don't care" argument. Right? That's a very common thing you'll hear, and in fact, if you don't have any regulation, you have incentive to be as unsafe as possible and externalize the costs of doing the wrong thing. You create an environment that basically optimizes for dangerous psychopaths. Now, as far as making sure people know their asses are on their line, I've got one trick. This is one I tend to use more as a last resort, but it can be kind of handy. I just like to come to someone sometimes and say, okay, hey, so we're about to launch, we're writing the ops playbook for this system, and if this certain event happens, we're going to need leadership to make some tough calls about the resulting legally or life consequential issue. Are you the decision maker for this? Right. The people who tend to be the worst problems tend to be the people who really, really want to be in the room. They never want an important product decision made without them, but they also really don't want to be in that room. That room means liability. That room means responsibility. Asking the innocent but obviously necessary question is a really good way to make these threats and the possibility of them happening a concrete thing in people's minds. So going back to our list, there's one last category. Sometimes you are dealing with genuine psychopaths. People whose incentives are tied to the short term, right? So they're going to launch and move on to the next thing, and they don't care whether the product succeeds in the long term, they're just going to fail upwards. And they genuinely don't care about other people. And if there are more senior people that can basically put a thumb down on them, then you should absolutely use those. But if this goes all the way up your hierarchy, if this goes all the way to the top, I don't have a great solution in that case. What I generally tend to suggest is polishing your resume. And this is also where, as a profession, we need to be organized so that they can't just go and hire someone else who's going to be less ethical. So let's sum up. What you build matters. Doesn't have to be a medical system to have a serious impact. There's stalking, bullying, job loss, all of these things, software can go wrong. Your work makes a difference. Safety includes everything. There ain't no such thing as out of scope. There is no I'm working on only security issues. That sounds like more of a privacy issue. I'm sure someone else will take care of it. That is the way things go horribly wrong. Just because someone used a system in a way we didn't expect doesn't mean it's not our problem. Users are part of your system. You can't say, oh, that's the user's responsibility. If it's your system and someone or something can get hurt, you need a plan. You need to embody safety. You need to be modeling threats from the moment you imagine that system. You need to know the threats as well as you know your own features. And that is you specifically. As StaffPlus engineers, you are the leaders who define your team's culture. If you do it right, your teams will follow. And if you do it wrong, your teams will follow. Now go do good work.